Welcome to the channel ICSE with Rishi sir. In this video, we are going to discuss about the class 10 ICSE physics. The chapter name is motion in one dimension and the chapter number is 4. So before we go to the video, I am going to tell one thing that the every video which is um, uh, coming that all are the short duration video and it might be 10 to 12 minutes maximum each video. Okay, so let's start with the motion in one dimension. So before we start motion in one dimension, we should know about the how many types of motions are there. That is the one dimension, or is there any other types of motions? Yes, there are so many types of motions, like the motion in one dimension, or motion in two dimension, or motion in three dimension, or motion in n dimension. So how can we distinguish the motion, the types of motion? So before we go into the specific topic, if we consider the motion in one dimension, it means the motion should be either positive x-axis, or the motion should be either negative x-axis, or the motion should be either positive y-axis, or motion should be negative y-axis. That means if we go from point A to B, that is if it is east, west, north, south. So if we go to the direction of east, then it is you can consider that it is a motion in one dimension. If we are going to west, then it is a motion of one dimension, and that motion should be in the straight line. The important key note is the motion should be in straight line. That's why this motion is often called rectilinear motion. Okay. Now, if you go from point A to B, that is one. That motion is a one-dimensional motion, or if a throne is fallen from up to down, this is also a one-dimensional motion, and it occurs in negative x y direction, or you can throw a ball from downward to upward, then these exhibits a one-dimensional motion having the trajectory of that is called the direction of positive y. Okay, so this is called the one dimensional motion. So what is the two dimensional motion? Now you consider you are going to up with some stair. So here you see that you should go the x direction, then you should go the y direction. It is again you go to the x, then y, like that. You can, this is a mixed motion where the at every instant of time, so the motion should be sometimes in x direction, sometimes in y direction, like this type of motion is called the two-dimensional motion. Or if you are going to one from one point to another point with a curvilinear point, that is the curvilinear motion, then this motion is also called a two-dimensional motion, as it is point A, this is point B, but every instant of time it goes some x direction, goes some y direction, again some x direction, some y direction. So this motion is often called the two-dimensional motion. But if it is this zigzag, this is called zigzag motion also. But if this zigzag motion is happened in a plane, that means in a plane you just move something from point A to B in a zigzag manner, that is the motion is zigzag, then this motion is called the motion in a plane. Like that, the motion is said to be a three-dimensional motion if the velocity of the particle is in space. So in space it is called 3D motion. Like that, if this is your dimension of the room, that is, this is the length of your room, this is the height of your room, this is the breadth of your room. You throw one particle from here and it goes like follow this trajectory. So at that point the coordinate of trajectory become L1 comma H1 comma B1, is it? So this, if you want to come in this point, then you should travel along L direction, along H direction, along B direction. So this is means you have to travel along X, Y, Z three coordinate. This is X coordinate, this is Y coordinate, and this is Z coordinate, and this is also a mixed motion called the three-dimensional motion. Now the another thing that should be associated in this topic and very important, that is the what is the state of an object. Important thing, the state of object. The state of object is of two types. One is, you can say, the body is at rest, and the second thing is the body is at motion. So, but one surprising thing is that this is the whatever the body is in rest or body is in motion, they are relative. That means when the body is in rest, when relative velocity of the body, of not of the body, velocity between two body is 0, then the body is, you can say that the bodies are rest with respect to each other. That means if body A have a velocity v1 and a body B having a velocity v2, the relative velocity VAB, that is the relative velocity, it is denoted by VA minus VB. Now VA minus VB is the relative velocity. Now a body is moving at a velocity v1 and the body B is moving with a velocity of v2. Okay, if v1 is equal to v2, then what is the relative velocity between A and B? If v1 is equal to v2, then what is the relative velocity between A and B? So both are in the same direction. So VA become v1 minus VB become v2. So what is v1 minus, you can replace v2 by v1, that means the 0. That means if two bodies are in the same velocity and traveling in the same direction, then they are relatively rest with each other. Means A particle see that B is at rest and B particle see that A is at rest. But if there is a third observer, that means you standing over there, then you see that both A and B are in the motion with respect to you, because your velocity v3 is equal to 0. Now if two bodies are in opposite direction, one is v1 and another is v2, then what is the relative velocity? This is particle A, this is particle B. So VAB is what? AB is equal to VA minus VB. So what is VA? VA is equal to V1. What is VB? VB is equal to minus of V2, because this is a velocity, and as velocity is a vector quantity, so it comes along with the direction. So velocity of, if this is the positive direction, then this is obviously negative direction. So the direction of v1 is positive and the direction of v2 is negative. So what is the effective velocity? V1 plus v2. It means that if two bodies are, if two bodies are moving with different velocity or same velocity with the opposite direction, then their velocity add up. And if they have the same velocity v and v, same velocity, with the same direction, then velocity is subtracted. So that means that depending upon depending upon that the observer or the reference frame, we can say the body is in rest or motion. That is called the inertia of the body. The state of the body is called the inertia of the body. Inertia of body. Okay. Now, uh, now the you can consider this is the earth, and earth is rotating at some velocity. Now everything which is inside the earth, that is also rotates along with the earth. That means that's why we are not observing that earth is rotating with a very high velocity. But if you go to the space or you go to the moon, then you can see that earth or the objects over the earth is rotating with a very high speed. That means the motion of a body or the body is in race, that is relative, that is dependent upon the observer. Okay. Now in this chapter there are few important concepts are there. That is we have to need some important concept that is the what is the speed, definition of speed, and the entire thing about the speed, velocity, then distance, then displacement, then acceleration. These are the very important things we have to know about it, that velocity is a vector quantity, displacement is a vector quantity, and the acceleration is a vector quantity. Okay. Now, another thing is that the motion in 1D, if we go through the bookish definition, then when you can say that when a body moves along a straight line, its motion is said to be one dimension, that is rectilinear linear motion. So this is the basic definition. Then on the other hand, if a body moves along a curved path, then it is a curvilinear motion or two-dimensional motion. But if that curved path is lie on a plane, then you can say that the motion in a plane. Then the third point is, if the body is in the moves in space, then its motion is the three-dimensional motion, and the state of the body is it means that the body will be in rest or it will be in motion, and that depends upon the observer or the or the surrounding of the body. These are the total summarization of this lecture. In the next lecture, we will discuss about the speed, velocity, distance, displacement, acceleration, all these things, and why velocity is a vector quantity, why displacement, acceleration, all are the vector quantity that we have to discuss. And we have to discuss one important thing, that is the force, because force is the game changer of the total entire topic. Okay, so see you in the next video. Goodbye.